Welcome to Still Science Lab. Tonight, we are going to dismantle the most absolute boundary in the universe and look at the terrifying, beautiful possibility of breaking it. For the entirety of human history, our species has looked up at the stars with a mixture of awe and profound longing, driven by an innate desire to cross the void and touch the distant lights that puncture the darkness of our night sky. We have mapped the constellations, named the galaxies, and calculated the orbits of worlds we will never see with our own eyes. Yet, as our understanding of physics has matured, that longing has been met with a cold, hard reality known as the cosmic speed limit. We have been told by the equations of Albert Einstein that light is the fastest thing there is, and that nothing with mass can ever hope to catch it, let alone surpass it. This rule has effectively locked us in a cosmic prison, confining humanity to a single solar system in a galaxy spanning 100,000 light-years. It dictates that we are born, we live, and we die within the gravitational embrace of our own sun, forever separated from the rest of the universe by an unbridgeable gulf of time and space. But tonight, we are investigating a fracture in those prison bars. Recent breakthroughs in theoretical physics have introduced a new class of warp drive solutions that do not require impossible energy or magic materials. We are talking about a method to travel 10 times faster than light, turning voyages of millennia into casual trips of a few months. We will explore the geometry of warp bubbles, the shift from negative to positive energy, and the profound implications of becoming an interstellar species. If you have ever wondered if we will truly reach the stars, stay with us, because the math is finally starting to say yes. To truly understand the magnitude of the solution we are about to discuss, we must first deeply respect the problem, because the distances involved in space travel are not merely far, they are devastatingly, incomprehensibly vast. When we talk about space in our daily lives, we usually refer to low Earth orbit, where the International Space Station circles, or perhaps the Moon, which is a mere 3 days away by rocket. But interstellar space is a different beast entirely. To put it in perspective, consider the fastest object human hands have ever built, the Parker Solar Probe. This engineering marvel utilizes the immense gravity of the Sun to achieve speeds topping 400,000 miles per hour. That is fast enough to travel from New York to Tokyo in under a minute. It is a speed that defies terrestrial comprehension, tearing through the vacuum faster than a bullet. Yet, if we were to take that record-breaking spacecraft and point it toward Proxima Centauri, our nearest stellar neighbor, the journey would take nearly 70,000 years. Let that number sink in. 70,000 years. That is a span of time longer than recorded human history. It is longer than the time since we emerged from the last ice age. If a crew departed Earth today in our fastest ship, their civilization would rise and fall, their languages would go extinct, the continents on Earth would shift, and the very memory of their mission would likely be lost to the sands of time before they even reached the halfway point. By the time they arrived, if the ship even survived, they would be ghosts arriving at a graveyard, completely disconnected from the world that sent them. This is the tyranny of the rocket equation and the vastness of the void. We are currently trying to cross an ocean by swimming one stroke at a time, and the physics of chemical propulsion simply cannot bridge the gap. We are using firecrackers to try and cross a galaxy, and the universe is laughing at our slowness. We need a paradigm shift, not just a better engine, because the issue isn't just engineering, it is the fundamental structure of space and time itself. The universe we inhabit operates on a scale that makes human life seem instantaneous. Light itself, the cosmic messenger, travels at 186,000 miles per second. It can circle the Earth 7.5 times in a single heartbeat. In our local neighborhood, this seems instantaneous. But zoom out, and even light begins to crawl. It takes light 8 minutes to reach us from the Sunday. It takes 4.5 years to reach Alpha Centauri. It takes 100,000 years to cross the Milky Way galaxy. If you were to look at our galaxy from the outside, watching a beam of light try to cross, it would be like watching a snail crawl across a continent. And the Milky Way is just one of billions of galaxies. The Andromeda Galaxy is 2.5 million light-years away. The light we see from it left before humans existed. This is the cosmic prison we speak of. We are trapped in a bubble of causality, able to see the past, but unable to touch the present of the universe around us. For decades, science fiction has offered us a way out, the warp drive. It was a convenient plot device in Star Trek, a way to move the story along so the characters didn't die of old age between episodes. But in the real world, it was dismissed as fantasy. The laws of special relativity are strict. As an object accelerates, its mass increases. As it approaches the speed of light, its mass approaches infinity, and the energy required to push it faster also becomes infinite. This is the asymptote, the vertical wall on the graph of physics that says, "You shall not pass." However, science is not a static book of rules. It is a living process of discovery. In 1994, a theoretical physicist named Miguel Alcubierre realized that while we cannot move through space faster than light, there is no rule in Einstein's general relativity that limits the speed at which space itself can move. This was the spark, the realization that the cage bars were not rigid steel, but flexible rubber. Tonight, we are looking at the evolution of that spark. For a long time, the Alcubierre drive was considered physically impossible because it required negative energy, a substance that likely doesn't exist in the quantities needed. It required the mass energy of the entire visible universe to move a single ship. It was a mathematical possibility, but a physical absurdity. But that has changed. In the last few years, and specifically in very recent papers published by physicists like Eric Lentz and Alexei Bobrik, the math has been rewritten. They have found solutions to the field equations that allow for superluminal travel warp speed using only positive energy. Ordinary mass, the stuff you and I and the stars are made of. They have brought the energy requirements down from the mass of the universe to the mass of Jupiter, and potentially even lower with further optimization. This implies that the barrier to the stars is no longer a fundamental law of nature, but merely an engineering challenge. A massive, terrified, exhilarating engineering challenge. We are standing on the precipice of a new era in physics, one where we stop looking at the speed of light as a limit and start looking at it as a baseline. Over the course of this deep dive, we will explain exactly how these new drives work. We will visualize the warping of space-time, the contraction of the void in front of a ship, and the expansion behind it. We will discuss the paradoxes of time travel that might arise, the potential weapons such a drive could create, and the sheer, raw power required to bend the fabric of reality. But we start here with the realization that the door is not locked. We just need to figure out how to turn the handle. The silence of the eternal night is about to be broken, not by the roar of a rocket engine, but by the hum of a space-time metric shifting. Welcome to the future of propulsion. Welcome to the era of warp. To truly grasp why the recent breakthroughs in warp drive physics are so revolutionary, we must first confront the seemingly invincible monster that has stood in our way for over a century: Albert Einstein's theory of special relativity. This isn't just a rule in a textbook, it is the operating system of the cosmos. Published in 1905, this theory established that the speed of light is not merely the speed of photons, but the speed of causality itself, the maximum speed at which any information or cause can travel to create an effect. The implications of this are brutal for space travel. The theory dictates that as any object with mass accelerates, its relativistic mass increases. At everyday speeds, this effect is negligible. A car moving down the highway gains an imperceptible amount of mass. But as you push closer to the speed of light, the curve spikes vertically. To accelerate a single electron to 100% of the speed of light would require infinite energy. To accelerate a spaceship to that speed is, therefore, physically impossible. This law suggests that the stars are not just far away, they are causally disconnected from us. We can see them, but we cannot touch them. For decades, this was the end of the conversation. The door was slammed shut, locked, and welded tight by the fundamental geometry of the universe. However, in 1994, a theoretical physicist named Miguel Alcubierre found a key that didn't just unlock the door, but dismantled the wall entirely. He was inspired not by a laboratory experiment, but by science fiction, specifically the warp drive of Star Trek. He asked a simple yet profound question: is there a solution within Einstein's own general relativity that allows for the effect of faster-than-light travel without violating the local speed limit of light? General relativity, unlike its special counterpart, deals with gravity and the curvature of space-time. It treats space not as a static stage where events happen, but as a flexible, dynamic fabric that can stretch, twist, and bend. We know space can expand because the universe itself has been expanding since the Big Bang. In fact, the distant edges of the universe are receding from us faster than the speed of light right now. This does not violate relativity because objects aren't moving through space. The space between them is growing. Alcubierre realized that if space can expand globally, it could theoretically be manipulated locally. This insight led to the mathematical formulation of the Alcubierre Metric, a specific solution to the Einstein field equations that describes a warp bubble. The concept is elegant in its simplicity, but terrifying in its requirements. Imagine a spacecraft sitting in a patch of flat, unwarped space. The drive activates. Behind the ship, the drive mechanism violently expands space-time, pushing the ship forward. In front of the ship, the drive violently contracts space-time, pulling the destination closer. The ship itself sits safely in the middle, inside a flat region of the bubble. To an outside observer, the bubble appears to be moving at 10, 100, or 1,000 times the speed of light. But inside the bubble, the ship is not moving at all. It has zero local velocity. This is the crucial distinction that allows the warp drive to cheat the cosmic speed limit. The ship never accelerates to the speed of light. The bubble of space around it does. Since space has no mass, it has no speed limit. To visualize this, think of a surfer on the ocean. The surfer is the spaceship. The ocean is space-time. If the surfer paddles with their hands, they are limited by their own physical strength and the drag of the water. This is conventional rocket propulsion. But if the surfer catches a wave, they are carried forward by the moving water. The surfer can stand perfectly still on the board, yet they are traveling at high speed relative to the shore. The warp drive creates its own wave. It surfs the fabric of reality. This mechanism also solves one of the most lethal problems of high-speed travel: inertia. If a conventional spaceship were to accelerate to light speed in a few seconds, The G-forces would instantly turn the crew into a thin paste on the back wall of the cabin. But in an Alcubierre drive, because the ship is not technically accelerating, the space around it is doing the work, the crew feels absolutely nothing. There are no G-forces. You could be traveling at 10 times the speed of light, sipping a cup of coffee, and the liquid wouldn't even ripple. It creates a pocket of calm in the midst of a space-time hurricane. However, describing the geometry of the bubble is the easy part. Fueling it is where the dream almost died. When Alcubierre first ran the numbers to calculate the energy density required to maintain such a distortion, the results were disheartening. The equations demanded that the space behind the ship expand, which requires a repulsive form of gravity. In our universe, gravity is attractive. Mass pulls on mass. To get gravity to push, you need something that violates the standard energy conditions of physics. You need negative energy, or exotic matter, stuff that has negative mass. If you had a ball of negative matter and pushed it, it would move toward you. While quantum field theory allows for tiny, fleeting amounts of negative energy to exist, such as in the Casimir effect, where two metal plates are pushed together by the pressure of the vacuum. Scaling this up to the size of a spaceship seemed impossible. Furthermore, the sheer quantity of this impossible energy was astronomical. The initial calculations suggested that to create a warp bubble just a few meters across, you would need an amount of negative energy equivalent to the mass of the entire observable universe. This effectively relegated the warp drive back to the realm of fantasy. It was a valid mathematical solution, but a physical impossibility. It was like having the blueprints for a skyscraper, but being told you need to build it out of solidified sunlight. Over the years, physicists like Chris van den Broek refined the geometry, shrinking the energy requirements down from the universe to a galaxy, and eventually to the mass of Jupiter. This was progress. Certainly, Jupiter is much smaller than the universe, but it was still an insurmountable engineering hurdle. Where does a civilization find a planet's worth of negative mass? The Alcubierre drive became a museum piece of theoretical physics admired for its beauty, but considered useless for actual exploration. It stood as a taunt, proving that the math allowed us to leave, but the physics kept us grounded. We were missing a piece of the puzzle. We needed a way to bend space without needing the energy of a dead star, and crucially, without needing matter that might not even exist in the macro universe. For nearly 30 years, the field stagnated here. Until recently, a new generation of physicists decided to stop trying to force the Alcubierre metric to work, and instead started looking for entirely new metrics. They asked, is there a way to arrange ordinary, positive mass, the stuff we have in abundance, in such a complex configuration that it mimics the effects of a warp drive without breaking the energy rules? This question led to the breakthrough we are discussing today, a shift from the impossible negative energy drive to the plausible positive energy soliton. This is the pivot point in history where the warp drive moved from a what-if to a how-to. We are no longer looking for magic, we are looking for geometry. And as we peel back the layers of these new solutions, we find that the structure of space-time is far more malleable than we ever dared to dream. The prison walls are still there, but we have found a loose brick, and we are starting to pry it open. For nearly 30 years, the dream of the warp drive languished in a purgatory of negative energy. It was a time of frustration for astrophysicists and dreamers alike, as the math stood like a tantalizing mirage, visible, clearly defined, yet composed of a substance that the universe seemed to forbid. The Alcubierre drive, for all its brilliance, had become a symbol of the unobtainable, a machine that required a fuel tank filled with a physical paradox. But science is rarely a straight line. It is a series of dead ends followed by sudden, blinding turns into new territory. The turn for warp drive physics came in the early 2020s, specifically with the publication of groundbreaking papers by physicists like Eric Lentz at the University of Göttingen and the team of Alexei Bobrik and Gianni Martir. These researchers did not merely tweak the variables of Alcubierre's equation, they fundamentally reimagined the geometry of the vessel itself, and in doing so, they performed a miracle of theoretical physics. They removed the need for negative energy. To understand how they did this, we have to look at the concept of the soliton. In the chaotic world of fluid dynamics, a soliton is a self-reinforcing wave packet that maintains its shape while it propagates at a constant velocity. If you have ever seen a perfect ring of smoke travel across a still room without breaking apart, or a rogue wave cross an ocean without losing its power, you have seen a soliton. Lentz was studying the physics of hyper-fast plasma configurations when he noticed a striking similarity between the equations governing these plasma waves and the equations of general relativity. He realized that there were soliton solutions to Einstein's field equations that had been overlooked, configurations of space-time curvature that could hold their shape and move at superluminal speeds, but which were constructed entirely from positive energy densities. This was the eureka moment. It meant that the warp bubble didn't need to be made of exotic matter or anti-gravity stuff. It could be made of plasma, radiation, or even electromagnetic fields, standard garden variety energy that we use and understand every day. The difference lies in the complexity of the geometry. Alcubierre's original model was relatively simple, a spherical bubble with a single layer of distortion. It was this simplicity that forced the math to demand negative energy to balance the books. Lentz and others proposed a much more intricate structure, often visualized not as a simple bubble, but as a series of hyperbolic layers or a toroidal, donut-shaped configuration. By arranging the energy in a specific, highly organized flow, essentially a complex architecture of stress-energy tensors, they found that gravity could be manipulated to create the propulsion effect without violating the weak energy condition. In layman's terms, they found a way to build the car out of steel and plastic instead of ghosts and magic. The Lentz soliton proved that there are configurations of matter that allow for faster than light travel while respecting the laws of conventional physics. The impossible sign had been taken down and replaced with a sign that read, "Under construction." This shift cannot be overstated. Before this, arguing for a warp drive was like arguing for a perpetual motion machine. It was an argument against the laws of thermodynamics. Now, arguing for a warp drive is like arguing for a Dyson sphere or a space elevator. It is no longer a question of if the laws of physics allow it, but how a civilization generates the engineering capacity to build it. Of course, the engineering capacity required is still terrifyingly high. While we no longer need the mass of the universe, the initial calculations for a positive energy warp bubble still demand an energy equivalence roughly equal to hundreds of times the mass of Jupiter. We are talking about converting the mass of a giant planet entirely into energy and structuring it into a precise geometric shell around a spacecraft. For a Type 0 civilization like ours, which still burns dead plants for electricity, this is effectively infinite. But for a Type 2 civilization capable of harvesting the full output of a star, it is merely a heavy expense. The work of Bobrick and Martier further refined this by introducing the concept of the warp shell. They analyzed the warp drive not just as a mathematical abstraction, but as a physical object, a vessel with a hull made of distorted space-time. They demonstrated that a warp drive is essentially a shell of material moving at a certain velocity, enclosing a passenger region. They showed that you could technically accelerate this shell to any speed, provided you have the energy to do so. Crucially, they also pointed out that the bubble doesn't necessarily accelerate itself. In their model, a warp drive might act more like a ferry. You accelerate the warp shell using conventional means to a high speed, and then, because of the time dilation effects and the geometry of the shell, the passengers inside experience the journey differently. While this specific interpretation has limits regarding breaking the light speed barrier from a standing start, it opened up the field to subluminal warp drives, ships that travel slower than light but use warp geometry to negate inertia and time dilation. This flurry of new research has transformed the field from a stagnant pool into a rushing river. We are now seeing a divergence of ideas. Some physicists are exploring superluminal solitons that go faster than light, while others are looking at subluminal warp bubbles that could get us to Mars in days without crushing the astronauts with G-forces. The conversation has shifted from proving it's possible to optimization. Just as the first computer filled a room and could barely do addition, the first warp drive calculations are bloated and inefficient. The goal now is to find the aerodynamic shape of space-time to whittle down the energy requirements from Jupiter mass to Moon mass, and eventually, perhaps, to the output of a nuclear fusion reactor. We are in the early days of space-time engineering. We must also address the reality of what positive energy implies for the ship's construction. In the Alcubierre model, the ship was passive. In the Lentz model, the ship is surrounded by a churning, violent storm of plasma or radiation, organized into magnetic traps or laser lattices, possessing a density comparable to the core of a neutron star. This is not a sleek, silver saucer gliding silently through the void. This is a brutal, high-energy machine. The walls of the warp bubble would be radiating heat and gravitational tides that would tear an unprotected ship apart. The engineering challenge is not just generating the field, but surviving it. We would need magnetic shielding of unprecedented strength, cooling systems that defy current thermodynamics, and a way to keep the passenger module causally disconnected from the incinerating energies of the propulsion shell. Yet, despite the formidable challenges, the psychological victory is total. The cosmic prison is not absolute. The bars can be bent by conventional matter. We have moved from the realm of the supernatural to the realm of the difficult. And humans are very, very good at the difficult. We split the atom, we mapped the genome, we landed on the moon with computers less powerful than a toaster. The positive energy warp drive is the new horizon. It tells us that the stars are not paintings on the ceiling of a locked room. They are lands across a wide, stormy ocean. We just need to build a boat strong enough to sail the currents of space-time. The math is the blueprint for that boat, and for the first time in history, the blueprint actually makes sense. We are no longer waiting for a miracle, we are waiting for a better power source. And in the grand scale of history, that is a problem we can solve. The realization that a warp drive can be constructed from positive energy is undoubtedly one of the most significant theoretical victories in the history of physics, but it brings us face to face with a new adversary that is almost as formidable as the laws of relativity themselves: the sheer, unadulterated scale of the energy required. When physicists say that the energy requirements have been reduced, they are speaking in relative terms. We have moved from needing the mass energy of the entire observable universe down to the mass energy of a gas giant like Jupiter. To a mathematician, this is a massive optimization, a reduction of dozens of orders of magnitude that proves the concept is sound. To an engineer, however, needing the energy equivalent of Jupiter is effectively the same as needing the universe. It represents a quantity of power that is so far beyond our current civilization's capabilities that it borders on the absurd. We are a species that struggles to transition from fossil fuels to renewables. The idea of harnessing the explosive potential of an entire planet and condensing it into a ring around a spaceship is, for the moment, pure science fiction. To visualize this challenge, we must revisit Einstein's most famous equation, E equals mc squared. This equation tells us that mass and energy are interchangeable. A small amount of mass contains a tremendous amount of energy. The nuclear bomb that destroyed Hiroshima converted only about 700 milligrams of matter into energy, roughly the mass of a paperclip. Now, imagine a machine that requires the conversion of mass on the scale of a planet. The Lentz soliton, in its initial unoptimized form, requires a sphere of energy density so intense that it would warp the fabric of reality simply by existing. If we were to switch on such a drive near Earth, the gravitational tidal forces alone would likely tear our planet apart or fling the moon out of its orbit. This is not an engine you turn on inside a harbor. It is a cosmic event. The energy density required to flatten space-time in front of the ship is comparable to the conditions found in the early universe, microseconds after the Big Bang. We are talking about carrying a piece of the primordial chaos in a bottle. However, just as the first steam engines were hopelessly inefficient compared to modern turbines, the first calculations for the positive energy warp drive represent the worst-case scenario. Theoretical physicists are already hard at work on the next phase of the problem, optimization. The goal is to find geometric configurations that reduce the volume of the warp bubble while maintaining the surface area required to encompass the ship. One proposed method involves making the walls of the warp bubble incredibly thin. Instead of a thick, churning shell of plasma, imagine a razor-thin membrane of hyper-compressed energy. By reducing the thickness of the shell, the total energy requirement drops precipitously. Some models suggest that with extreme optimization using oscillating fields or pulsed warp bubbles, we might bring the energy requirement down to the mass of a large asteroid, or perhaps even the moon. While still astronomical, this brings the concept within the theoretical limits of a Type II civilization on the Kardashev scale, a society capable of harvesting the total energy output of their sun. Another major hurdle that arises when we move from math to mechanics is the horizon problem. This is a paradox rooted in the fact that the warp bubble is moving faster than light. If the ship is traveling at 10 times the speed of light, the front of the warp bubble is moving into new space faster than any signal from the ship can reach it. This means the crew inside the bubble is causally disconnected from the front wall of their own vessel. They cannot send a radio signal, a laser beam, or a control pulse to the front of the drive to tell it to turn, stop, or adjust power. The ship is effectively flying blind, unable to see what is coming and unable to steer the mechanism that is pulling it forward. This creates a terrifying scenario where a warp ship, once activated, might be unstoppable from the inside, a runaway train tearing through the galaxy until it runs out of fuel or collides with a star. To solve the horizon problem, physicists have proposed placing the engine not on the ship, but on the bubble itself, effectively programming the trajectory before launch, or perhaps arranging the geometry such that a sliver of the bubble remains subluminal, acting as a control window. Others have suggested that we might never be able to build a ship that can accelerate itself to warp speed. Instead, we might build warp highways, massive, stationary rings in space that generate the bubble and push the ship through like a railgun. The ship would be a passive rider, and the infrastructure would handle the heavy lifting of space-time manipulation. This would solve the control issue, as the tracks would determine the destination, but it would limit travel to fixed routes, turning the galaxy into a network of train lines rather than an open ocean. Furthermore, we must consider the internal environment of the warp bubble. While the passenger cabin sits in a flat region of space-time, the walls of the bubble are regions of extreme gravitational curvature. According to quantum field theory, such extreme curvature should generate a tremendous amount of Hawking radiation, the same theoretical radiation that causes black holes to evaporate. As the bubble sweeps through the quantum vacuum, it could generate a scorching bath of particles that would cook the interior of the ship. The calm eye of the storm might actually be a microwave oven. Shielding the crew from their own engine becomes as critical as building the engine itself. We would need materials capable of blocking radiation intensities that we have never encountered in nature, or we would need to design the geometry of the bubble to direct this radiation outward, turning the ship into a glowing beacon of death for anything that happens to be passing by. There is also the matter of interstellar debris. Space is not truly empty. It is filled with dust, gas, and micrometeoroids. When a conventional spaceship hits a grain of dust at orbital speeds, it can leave a crater in the window. But what happens when a warp bubble hits a grain of dust at 10 times the speed of light? The dust particle doesn't just hit the ship, it hits the warped space-time. Some theories suggest the dust would be swept around the bubble, surfing the gravitational wave harmlessly, but other calculations suggest the dust would be trapped in the high-energy shell, accumulating over the course of the journey. As the ship travels light years, it would sweep up terajoules of energy in the form of trapped particles. When the ship arrives at its destination and the bubble collapses, this accumulated energy would be released in a single, focused blast of gamma rays and high-energy particles directly in front of the ship. This is known as the warp drive doomsday argument. It suggests that arriving at a planet might inadvertently sterilize it. We would be the cosmic equivalent of a shotgun blast announcing our arrival. These challenges paint a picture of a technology that is incredibly violent and difficult to tame. The warp drive is not the gentle humming engine of Star Trek. It is a brute force manipulation of the fundamental constants of nature. It requires taming the energy of stars, navigating blind through the void, and shielding ourselves from the quantum firestorms we create. Yet, strangely, this makes the concept more credible, not less. If the math said it was easy, we would suspect a mistake. The fact that the math predicts extreme difficulties that align with our understanding of high-energy physics suggests that we are on the right track. We are uncovering the actual blueprints of the universe's mechanics. The engineering nightmares are proof that we have left the realm of pure fantasy and entered the realm of hard, cold, solvable physics. We are no longer asking for magic wands. We are asking for better heat shields, stronger magnets, and denser batteries. And as any engineer will tell you, those are problems that can be solved given enough time and enough motivation. We are beginning to see the warp drive not as a dream, but as a machine, a complex, dangerous, magnificent machine that is waiting to be built. While the engineering challenges of building a starship capable of manipulating the fabric of space-time are titanic, forcing us to confront the limits of our energy generation and material science, there is a profound difference between difficult and impossible. The shift in theoretical physics from negative energy requirements to positive energy solitons has moved the warp drive from the realm of magic to the realm of engineering. But theory is only words on a page until it is tested in the crucible of reality. You might be surprised to learn that we are not just waiting for a distant future to test these ideas. We are already probing the edges of warp physics in laboratories right now. The bridge between the chalkboard and the launch pad is currently being built by a small, dedicated cadre of researchers who are looking for the microscopic signatures of space-time distortion. One of the most significant figures in this modern pursuit is Dr. Harold "Sonny" White, a former NASA physicist who led the EagleWorks laboratory and now conducts research at the Limitless Space Institute. For years, Dr. White and his team have been investigating the geometry of warp bubbles, specifically looking for ways to optimize the Alcubierre metric to reduce the energy requirements. However, science often happens when you are busy looking for something else. In 2021, while conducting an analysis of custom Casimir cavities, microscopic structures designed to study the quantum vacuum, Dr. White's team made a startling, accidental discovery. They observed a distribution of energy density that exactly matched the mathematical predictions for a warp bubble. To be precise, it was a micro-scale, nano-fabricated structure that generated a negative vacuum energy distribution, which, mathematically speaking, is the seed of a warp field. They did not build a warp drive. They didn't send a hamster to Alpha Centauri, but they discovered a real-world, physical structure that creates the geometry required for a warp bubble. This was the first time in history that a warp bubble structure was not just a line of code in a simulation, but a physical phenomenon observed in a lab. This discovery centers on the Casimir effect, a quantum phenomenon that proves the vacuum of space is not empty. In quantum field theory, the vacuum is a roiling ocean of virtual particles popping in and out of existence. If you place two uncharged metallic plates extremely close together, mere nanometers apart, the number of virtual particles that can fit between them is limited by the gap, while the number of particles outside the plates is infinite. This creates a pressure difference that pushes the plates together. This negative pressure, or negative vacuum energy, is exactly the kind of exotic condition that Alcubierre's original equations demanded. While the new Lentz solutions allow for positive energy drives, the validation of Casimir geometries proves that humanity has the toolset to manipulate the quantum vacuum. We are like the early experimenters playing with static electricity, unaware that our sparks will one day power cities. We have found the match. Now we just need to build the bonfire. This transition from theory to accidental discovery parallels the history of nuclear physics. In the 1930s, splitting the atom was a theoretical novelty until Enrico Fermi built the Chicago Pile 1, a crude, dangerous pile of graphite and uranium under a football stadium. It didn't power anything, it barely lit a light bulb, but it proved the chain reaction was real. The micro-warp bubbles being studied today are our Chicago Pile. They are proof of principle. They tell us that the universe allows this geometry to exist. The next steps involve scaling up, creating larger arrays of these Casimir cavities, or finding ways to use intense magnetic fields to replicate the effect on a macro scale. DARPA, the Defense Advanced Research Projects Agency, has funded studies into these phenomena, not because they expect a starship tomorrow, but because they recognize that mastering the quantum vacuum is the ultimate high ground of strategic technology. But while we struggle to build the first prototype in our terrestrial cradles, we must ask ourselves a terrifying and exhilarating question. Has someone else already done it? If the physics allows for warp drives, and if the galaxy is billions of years older than humanity, then it is statistically probable that other civilizations have already solved the engineering hurdles we are currently facing. If the galaxy is a forest, surely there are other travelers on the paths. This brings us to a new frontier in the search for extraterrestrial intelligence, or SETI. For 60 years, we have pointed radio telescopes at the sky, listening for the beep-beep of alien communications. We have been waiting for a phone call, but perhaps we should be listening for the sound of their engines. A warp drive, by its very nature, is a massive gravitational event. It involves the movement of moon-sized masses or the compression of energy densities comparable to stars. When such a vessel accelerates or decelerates, it should ripple the fabric of space-time, sending out gravitational waves. We now possess the ears to hear these ripples. The Laser Interferometer Gravitational Wave Observatory, or LIGO, gave humanity a new sense, the ability to feel the vibration of the universe. Since 2015, LIGO has detected the collisions of black holes and neutron stars, events so cataclysmic that they shake the very grid of reality. However, physicists have begun to calculate what the gravitational signature of a warp drive would look like. Unlike the chaotic chirp of a spiraling black hole collision, a warp drive would likely produce a distinct, structured signal. As a ship accelerates to superluminal speeds, the warp bubble would generate a burst of gravitational radiation. Even more potent would be the signal of a warp drive failure or a containment breach. If a civilization attempted to jump to warp and their bubble collapsed catastrophically, the release of energy would be akin to a supernova, but with a unique gravitational footprint that doesn't match any natural celestial object. A paper published by astrophysicists at Queen Mary University of London and the University of Potsdam suggests that current and future gravitational wave detectors, like the space-based LISA mission, might be sensitive enough to detect these warp signatures all the way across the Milky Way. This changes the game completely. We don't need aliens to want to talk to us. We just need them to be driving around. Imagine the implications. We could wake up one morning to the news that LIGO has detected a repetitive, artificial signal originating from the direction of the Kepler field, a convoy of starships moving between systems. It would be the ultimate validation of our own physics. It would prove that the barrier can be broken and that the silent universe is actually buzzing with the traffic of civilizations that have graduated from chemical rockets to space-time manipulation. This leads us to the concept of active gravitational SETI. Instead of passively waiting, we are now combing through the data of existing detectors, looking for anomalies that were previously dismissed as noise. There are thousands of glitch events in LIGO's data signals that didn't match the templates of black holes and were discarded. What if one of those glitches was the startup sequence of a starship leaving the Orion Nebula? What if the background hum of the universe contains the faint echoes of a galactic federation? The search for warp drives turns astronomy into archaeology and espionage combined. We are looking for the exhaust fumes of giants. Furthermore, the detection of a warp signature would solve the Fermi paradox, the question of where is everyone? If warp travel is possible, why haven't they visited us? Perhaps they have, but the rules of warp travel dictate that you cannot enter a gravity well like a solar system while at warp. They might zoom past in the interstellar void, utilizing warp highways between the stars, bypassing the slow, uninteresting backwaters like our solar system. Or perhaps the energy cost is so high that warp travel is reserved for critical missions, not tourism. By understanding the physics of the warp drive, we begin to understand the constraints and the logic of potential alien civilizations. We stop projecting our human desires onto them and start analyzing them through the lens of what is physically possible. We are beginning to think like a galactic species before we even leave our own house. The laboratory experiments and the astronomical search are two sides of the same coin. One trying to build the future, the other trying to see if the future has already happened somewhere else. As we celebrate the triumph of the positive energy soliton and the potential engineering pathways to the stars, we must pause to confront a ghost that haunts the equations of every faster-than-light theory. It is a problem far deeper than energy density, radiation shielding, or material stress. It is a problem of logic. In the universe, as described by Albert Einstein, space and time are woven together into a single fabric called space-time. This means that moving through space is inextricably linked to moving through time. Under the strict rules of special relativity, the faster you move through space, the slower you move through time relative to a stationary observer. But when you cross the threshold of light speed, the math doesn't just get weird, it breaks the fundamental narrative of the universe. To put it bluntly, in relativity, faster-than-light travel is geometrically indistinguishable from time travel. If we build a warp drive that takes us to Alpha Centauri in 5 months, we may inadvertently build a machine that can send messages or weapons into our own past. This brings us face to face with the paradox of causality, the single biggest theoretical argument against the existence of warp drives. To understand why this happens, we have to abandon our intuitive understanding of now. On Earth, we share a universal clock. Now is the same for everyone. But in the cosmos, now is relative. It depends entirely on your speed and direction. Imagine two events happening at different ends of the galaxy. For a stationary observer, they might happen simultaneously. But for an observer moving at near light speed toward one of them, the order of events can flip. This is known as the relativity of simultaneity. As long as everyone moves slower than light, the causal order is preserved. The cause always happens before the effect. But if you introduce a warp drive that can outrun light, you can technically outrun the cause. You can fly away from Earth, turn around, and accelerate in a specific trajectory that allows you to arrive back at Earth before you left. This creates a closed time-like curve, a loop in history where you could technically walk into the launch bay and stop yourself from leaving. This leads to the classic grandfather paradox. If a warp ship allows you to travel back in time and you accidentally kill your grandfather before your father is born, then you were never born. But if you were never born, you couldn't have built the warp ship to go back and kill him. So, do you exist or not? The universe, as far as we know, relies on a strict progression of cause and effect to function. Physics is essentially the study of how one thing leads to another. If the warp drive breaks this chain, it suggests that the universe essentially crashes like a computer running a bad line of code. This led the late Stephen Hawking to propose the chronology protection conjecture, which essentially suggests that the laws of physics will conspire to prevent time travel. Hawking argued that whenever a machine like a warp drive attempts to create a closed time-like curve, vacuum fluctuations will build up to infinite levels and destroy the machine instantly. In this view, The universe has a built-in immune system, and a warp drive is a virus that triggers a fatal fever. However, the new positive energy solutions offer a potential escape route from this logical nightmare. Some physicists argue that a warp drive doesn't actually accelerate the ship locally, it moves the bubble. Since the ship inside remains in a flat space-time, it might be protected from the relativistic effects that cause time travel. Other theories suggest that while FTL travel is possible, the geometry of the universe prevents the formation of time loops. It might be that you can travel to a star faster than light, but the math of the return journey forbids you from arriving before you left. You might be forced to take a longer path through space-time on the way back, balancing the books of causality. This would mean the universe allows FTL, but strictly enforces a no U-turn policy in the temporal dimension. We don't yet know if this is true, but finding out is one of the most dangerous experiments a civilization could ever run. We are effectively testing the source code of reality to see if it has error handling. Beyond the headache of time travel, there is a darker, more visceral implication of warp technology that we must discuss: weaponization. Any technology that can propel a ship to 10 times the speed of light is, by definition, a weapon of mass destruction. In conventional warfare, kinetic energy is determined by mass and velocity. A bullet does damage because it moves fast. An asteroid does damage because it is heavy and moves fast. Now, imagine a spacecraft with the mass of a Boeing 747 moving at 10 times the speed of light. If such an object were to impact a planet, the energy release would be incalculable. It wouldn't just be a crater, it would be a mantle-cracking event. The sheer kinetic energy, or rather, the disruption of space-time energy upon impact, would likely sterilize the biosphere of the target world instantly. This introduces the relativistic kill vehicle concept. A civilization with warp drive doesn't need nuclear warheads or Death Stars. They just need to strap a warp engine to a rock and point it at an enemy planet. The terrifying part is that because the object is moving faster than light, the target would never see it coming. Light is the information carrier of the universe. If the rock moves faster than light, it arrives before its image does. One moment, the sky is blue and peaceful. The next nanosecond, the planet is vaporized. There is no warning, no radar signature, no time to launch interceptors, and no possibility of diplomacy. The war is over before the victim even knows it has started. This reality might explain the great silence of the universe. Perhaps civilizations that discover warp drive inevitably destroy themselves, or perhaps they form a shaky, mutually assured destruction pact that keeps everyone hiding in the dark, afraid to turn on their engines lest they reveal their location to a predator. This dual nature of the warp drive, as the ultimate vessel of exploration and the ultimate weapon of annihilation, forces us to mature as a species before we can use it. We are currently a fractured civilization, divided by borders, ideologies, and resource wars. We still point nuclear missiles at each other. Handing a warp drive to humanity in its current state would be like handing a loaded machine gun to a toddler. It suggests that the barrier to the stars is not just technological, but sociological. To survive the warp era, a civilization must likely evolve past the concept of planetary warfare. The physics demands a level of responsibility that we have not yet demonstrated. The filter that stops us from reaching the stars might not be the speed of light, it might be our own aggression. Yet, despite the risks of paradoxes and weaponization, the research continues. Why? because the drive to explore is more powerful than the fear of destruction. We are betting that the universe is not a trap. We are betting that there is a way to navigate the timeline without breaking it. Theoretical physicists are now exploring asymptotic flatness and global hyperbolicity, complex mathematical conditions that might allow for superluminal travel without causal violations. They are looking for the safe lanes in the geometry of the cosmos. It is a high-stakes game of chess against the laws of nature. If we win, the galaxy opens up to us. If we lose, we might accidentally edit ourselves out of history. But the very fact that we are asking these questions, that we are identifying these dangers, is a sign of progress. We are no longer blindly dreaming of Star Trek. We are meticulously planning the logistics of a godlike power. The warp drive is forcing us to grow up, to understand that with infinite speed comes infinite consequence. With the theoretical foundations of the positive energy warp drive established and the existential risks of causality violations acknowledged, we must now turn our attention to the practical experience of the journey itself. If we were to step aboard the USS Alcubierre and engage the drive, what would we actually see out of the window? Hollywood has conditioned us to expect star lines, white streaks of light stretching into infinity as the ship accelerates. However, the physics of relativity dictates a visual experience that is far more bizarre and terrifying. As the warp bubble forms and the ship accelerates past the speed of light, the view of the universe would undergo a radical transformation due to the relativistic Doppler effect and the aberration of light. Light coming from stars in front of the ship would be shifted to higher and higher frequencies, moving from the visible spectrum into ultraviolet, then X-rays, and finally gamma rays. This is known as blue shifting. To the naked eye, the stars ahead would not streak. They would simply disappear, fading into invisible, lethal radiation. Conversely, the light from stars behind the ship would be red-shifted into infrared and radio waves, vanishing into the dark. The only visible light would come from a narrow band of the cosmos, directly perpendicular to the ship's motion, creating a ring of distorted starlight around the vessel. The crew would effectively be flying inside a dark tunnel, with the entire universe compressed into a glowing, rainbow-colored donut of light encircling them. This searchlight effect means that a warp ship travels in blindness. You cannot navigate by looking out the window because the window is showing you a distorted, outdated, and radiologically hazardous false image of reality. This blindness introduces the supreme challenge of interstellar navigation. In a conventional rocket, if you drift off course, you can take a star sighting, triangulate your position, and correct your trajectory. But at 10 times the speed of light, you are moving faster than the information needed to navigate. You are outrunning the photons that tell you where the stars are. Therefore, a warp jump must be calculated with absolute precognitive precision before the drive is ever engaged. This is not like driving a car, it is like firing a bullet. Once the trigger is pulled, the trajectory is set. Navigators would need 4D maps of the galaxy that account for the proper motion of stars over time. Remember, stars are not stationary. They drift, orbit, and bob through the galactic disk. A map from 10 years ago is useless. We would need to know exactly where Proxima Centauri will be in 5 months, down to the meter. A miscalculation of a fraction of a degree over a distance of 4 light-years would result in the ship arriving billions of miles off target, lost in the deep void with no fuel to return. Furthermore, the navigational computer must account for the gravitational potholes of the galaxy. Space-time is not a smooth sheet. It is a bumpy terrain filled with the gravity wells of rogue planets, brown dwarfs, and dark matter clumps. If a warp bubble encounters a sudden, steep gravitational gradient, like passing too close to an undetected black hole, the tidal forces could destabilize the soliton field. The bubble could collapse instantly, or worse, be deflected onto a chaotic trajectory. This implies that the early days of warp travel will not be open ocean exploration. We will likely be restricted to safe lanes, heavily surveyed corridors of space that have been scanned by subluminal probes for centuries to ensure they are free of gravitational hazards. We will build highways in the sky, and leaving them would be an act of suicide. Navigating the void also requires shielding the ship from the interstellar medium. We often think of space as empty, but it is filled with a tenuous soup of hydrogen atoms, dust grains, and cosmic rays. At orbital speeds, these are negligible. At 10 times the speed of light, a single hydrogen atom hits the front of the warp bubble with the kinetic energy of a high-energy particle accelerator beam. The sheer friction of moving through the vacuum's dust would generate immense heat and radiation. The warp ship would need a deflector dish, a massive magnetic field generator designed to sweep the path clear of ionized particles before the bubble hits them. Without this, the front of the warp field would erode, and the radiation bath would cook the crew. This turns the ship into a snowplow, pushing a wave of blazing plasma ahead of it as it tears through the dark. So, assuming we survive the blindness, the navigation errors, and the interstellar friction, where do we go? The first destination is obvious: Proxima Centauri. Located just 4.2 light-years away, it is a red dwarf star hosting at least 2 planets, one of which, Proxima b, is in the habitable zone. In a warp ship moving at 10 times light speed, the journey would take approximately 5 months. This is comparable to a sea voyage from Europe to Australia in the 18th century. It is a long trip, but a survivable one. Upon arrival, we would not find a second Earth. Proxima b is likely tidally locked, meaning one side faces the star forever in eternal day, while the other freezes in eternal night. The habitable strip would be the twilight zone between the two. The star itself is a flare star, prone to violent outbursts of X-rays that might have stripped the planet's atmosphere away long ago. Our first warp mission might be a disappointment, finding only a blasted rock, but the scientific value of standing on an alien world, measuring its magnetic field, and drilling into its crust would be immeasurable. It would prove we can do it. Beyond Proxima lies the true prize: the TRAPPIST-1 system, located about 40 light-years away. At Warp 10, this is a 4-year journey, a significant commitment, but within the realm of a single mission profile. TRAPPIST-1 is the crown jewel of exoplanetary science, hosting 7 Earth-sized planets packed tightly together. 3 of them are in the habitable zone. Standing on the surface of one, you would see the other planets in the sky, appearing as large as our moon, clearly visible as spheres with clouds and oceans. It is a solar system that looks like a science fiction book cover. If life exists anywhere in our neighborhood, it is likely there, swapping biological material between the planets via asteroid impacts. A mission to TRAPPIST-1 would not just be an exploration, it would be a colonization effort. The sheer density of real estate there offers humanity a second home, a place to branch off from the phylogenetic tree of Earth. However, the journey to these worlds introduces a profound psychological barrier, known as the break-off phenomena. Astronauts in orbit often report the overview effect, a cognitive shift that happens when seeing Earth from space. Realizing its fragility, warp travelers would experience the break-off. As they exceed light speed, Earth doesn't just get smaller, it vanishes from the causal present. They are effectively entering a different timeline of experience. Even if they have subspace communicators using quantum entanglement, which is theoretically dubious, the sense of isolation would be absolute. They are further from home than any human has ever been, separated not just by distance, but by the physics of light itself. If something goes wrong, no one is coming to save them. The rescue signal would take 40 years to reach Earth. They are on their own in the most literal sense possible. This demands a new kind of astronaut psychology, people who are capable of severing the emotional tether to their home planet, perhaps forever. Ultimately, the first warp ships will be less like the sleek vessels of Star Trek, and more like the wooden ships of the Age of Discovery, cramped, dangerous, scurvy-ridden vessels sailing off the edge of the map. They will be filled with people who know they might never return, driven by a curiosity that overrides the survival instinct. They will face the monsters of the deep, rogue black holes, radiation storms, and the crushing silence of the void. But they will also be the first eyes to see a sunrise of a different color, the first lungs to breathe air filtered from an alien atmosphere, and the first hands to touch soil that was not born from our sun. Part 7 of our saga is about the realization that the warp drive is just the tool. The courage to use it is the real fuel. We are building the ship, but we must also build the sailors who can withstand the crushing weight of the infinite. And when they finally step out onto that red-lit soil of Proxima b, looking back at our sun, which will appear as just another bright star in the constellation of Cassiopeia, they will know that humanity is no longer a planetary species. We will have become children of the galaxy. As we delve deeper into the reality of life aboard a superluminal vessel, we must address the single most disorienting concept in the physics of space travel, the flow of time itself. For over a century, science fiction and popular science have conditioned us to believe that reaching the stars requires a terrible sacrifice. We have been taught the twin paradox, a consequence of Einstein's special relativity, which dictates that the faster you move through space, the slower you move through time. In this classic scenario, one twin stays on Earth, while the other boards a rocket traveling at 99% of the speed of light. To the traveling twin, the journey might feel like a few weeks, but when they return, they find the Earth aged by decades. Their twin is an old man or long dead, and the world they knew has crumbled into dust. This phenomenon, known as time dilation, paints interstellar travel as a one-way trip into the future, a tragic disconnection from the timeline of humanity. It suggests that to be an explorer is to be an exile, forever out of sync with the people you love. However, the positive energy warp drive offers a profound and beautiful exemption from this tragedy. Because the physics of the warp drive are fundamentally different from the physics of a conventional rocket, the rules of time dilation do not apply in the same way. Remember, inside the warp bubble, the ship is not moving relative to its local space-time. It is at rest. The bubble is moving, surfing the wave of expanding and contracting geometry, but the ship itself has zero local velocity. This means that the gamma factor, the variable in Lorentz equations that dictates how much time slows down, remains equal to 1. In layman's terms, the clock on the wall of the spaceship ticks at the exact same rate as the clock on the wall of mission control back on Earth. If the journey to the TRAPPIST-1 system takes 4 years, the crew ages 4 years, and the people on Earth age 4 years. There is no time slip. There is no interstellar moment where a father misses his daughter's entire life while he is away for an hour. This synchronization is the killer app of the warp drive. It is the feature that makes a true galactic civilization possible. If every voyage resulted in a time desynchronization, trade would be impossible. You couldn't ship goods between stars if the market you were selling to had ceased to exist by the time you arrived. You couldn't maintain a military alliance if the reinforcements arrived 3 centuries too late. The warp drive preserves the universal now, allowing humanity to expand across a volume of space hundreds of light years across, while remaining within the same temporal generation. It allows a captain to video call home, assuming we solve the faster-than-light communication problem, and speak to their spouse in real time, or at least with a manageable delay, rather than sending a message into a bottle that will only be opened by their great-grandchildren. It keeps the human narrative intact, ensuring that the colonies are not just archaeological curiosities to the homeworld, but active, contemporary extensions of our society. But while the flow of time inside the bubble is normal, the physical environment is anything but. We must consider the sensation of movement, or rather, the lack of it. In a conventional spacecraft, the crew feels acceleration. When the engines fire, they are pushed back into their seats. This G-force creates a sense of weight, but in a warp drive, because the ship is in freefall within the bubble, there is absolutely no sensation of acceleration. The ship could jump from a standstill to 10 times the speed of light in a single nanosecond, and the coffee in the captain's cup wouldn't even ripple. There is no inertia to overcome, because the ship isn't pushing against space. Space is carrying the ship. This means that a warp ship effectively operates in zero gravity at all times during the transit. Unless the ship is designed with rotating centrifuge sections to simulate gravity, the crew would be floating for the entire duration of the voyage. This presents long-term health risks, such as muscle atrophy and bone density loss, necessitating that warp ships be massive, rotating cylinders rather than the sleek, flat saucers we often visualize. However, the most dangerous part of the ship is not the zero-gravity interior, but the bubble wall itself. The boundary between the flat space-time inside the ship and the warped space-time of the drive field is a region of extreme tidal forces. If you were to walk to the edge of the ship and stick your hand out into the field, the gravitational gradient would be so steep that it would likely shear your atoms apart. The difference in the pull of gravity between your fingertips and your wrist would be measured in millions of Gs. This means the warp field acts as an invisible, lethal hull. We would likely need physical barriers to prevent the crew or any loose equipment from drifting too close to the event horizon of the bubble. A loose bolt floating into the warp field wouldn't just be crushed. It might destabilize the delicate harmonic resonance of the soliton, causing the entire bubble to collapse catastrophically. The crew is essentially living inside the eye of a gravitational hurricane, safe only as long as they stay in the absolute center. Furthermore, we must address the thermodynamic nightmare inside the bubble. In space, heat is a killer. A spaceship generates heat from its electronics, its life support systems, and the bodies of the crew. In a normal ship, this heat is radiated away into the vacuum via giant radiator panels. But inside a warp bubble, the ship is surrounded by a shell of high-energy distortion. Radiating heat out through the bubble wall might be impossible, as the distorted space-time could reflect the infrared radiation back at the ship. The warp bubble could act as a perfect thermos bottle, trapping all the heat inside. Over a journey of months, the internal temperature would rise steadily until the ship became a pressure cooker. Engineers would need to develop heat sinks, perhaps tanks of liquid helium or phase change materials to absorb the thermal load for the duration of the trip, or find a way to vent heat through the turbulent geometry of the field without destabilizing it. There is also the eerie silence of the journey. Because the ship is moving faster than light, it is outrunning any sound, any radio wave, and any light that originates from behind it. But more disturbingly, the ship is chemically isolated from the universe. In a normal vessel, you can open a valve and sample the interstellar gas. In a warp ship, the bubble wall creates a hermetic seal. Nothing gets in and nothing gets out. The crew is hermetically sealed in a pocket universe, cut off from the chemical reality of the galaxy. This isolation reinforces the psychological break-off we discussed earlier. You are not just far away, you are essentially in a different dimension of space-time that happens to be sliding through our own. The viewports show darkness or distorted rainbows, the sensors show static, and the only reality that exists is the metal shell around you. This environment demands a crew that is psychologically bulletproof. They are living in a zero-G, heat-trapping, time-synced, lethal-edged canister sliding through the dark at impossible speeds. They are the most isolated human beings in history, yet they carry the burden of being the most connected generation of explorers, capable of returning home to tell the tale. The resolution of the twin paradox is a gift, but it comes wrapped in the challenge of survival. We have traded the tragedy of time dilation for the engineering horror of the bubble wall. But as we look at the trade-off, it is one we are willing to take. To keep our families, to keep our timeline, and to keep our history unified, we will brave the eye of the storm. We will build the rotating hulls, we will install the massive heat sinks, and we will learn to live next to the razor's edge of the warp field. Because the alternative, arriving at the stars only to find our home has turned to dust, is a price too high to pay. As we continue to dissect the reality of superluminal travel, we must address a recent theoretical pivot that has fundamentally altered our understanding of what a warp drive actually is. For decades, following Alcubierre's initial proposal, we viewed the warp drive as a field effect, a manipulation of geometry that a spaceship generates around itself, effectively pulling the universe toward it. We imagined a captain on the bridge saying, "Engage," and the ship's engines creating the bubble and pushing it forward. However, a landmark paper published in 2021 by physicists Alexei Bobrik and Gianni Martire in the journal Classical and Quantum Gravity forced us to rethink this entire architecture. They demystified the warp drive, stripping away the esoteric field language and describing it in terms of standard general relativity. A warp drive is simply a shell of material. It is a physical object, a container made of matter or energy that separates the space-time inside from the space-time outside. This might sound like a subtle semantic difference, but the implications are ground-shaking. Bobrik and Martire demonstrated that a warp drive behaves much like any other object in the universe. It has mass, it has inertia, and, crucially, it must be accelerated. In Alcubierre's original mathematical abstraction, the bubble was treated almost like a massless geometric trick that could accelerate instantly to infinite velocity. But in the physical warp drive model, the shell itself possesses energy and therefore mass. To move the shell, you need propulsion. This brings the dreaded rocket equation back into the picture. You cannot just turn on the warp drive and be at 10 times light speed. You have to push the massive shell of distorted space-time up to speed. This revelation suggests that a warp ship might not be a self-propelling vessel, but rather a passenger inside a massive, externally powered transport container. Here is the catch that keeps physicists up at night. the superluminal barrier. The Bobrick-Martier equations suggest that while a warp shell can move faster than light, it cannot accelerate past the speed of light from a standing start using internal thrusters. If the shell is made of normal, positive energy matter, it is subject to the same speed limits as a rock or a rocket. It can travel at 99% of the speed of light, but it cannot cross the threshold. To exist at superluminal speeds, it essentially needs to be born moving faster than light, or it needs to be manipulated by an external force that is already operating in a superluminal regime. This implies that we cannot build a ship on Earth, launch it, and accelerate to warp 10. The transition from slower than light to faster than light remains a wall of infinite energy, even for a warp shell, unless we find a way to cheat the acceleration phase. This leads us to the concept of the warp highway or the relay system. If a ship cannot accelerate itself to warp speed, it might need to be thrown. We are looking at a future where interstellar travel is not about independent ships roaming the void, but about massive, stationary infrastructure. Imagine a series of colossal gateways, or mass drivers, built in deep space machines, capable of generating intense, focused gravitational waves, or laser propulsion beams. A warp shell would enter the gateway, and the station would impart the energy required to snap the shell into a superluminal trajectory. The ship inside is merely the rider. The gateway provides the push. This transforms the galaxy from an open ocean into a railroad network. We would be limited to traveling between specific nodes where the infrastructure exists. The first mission to a new star would be a slow, subluminal crawl to build the exit gate on the other side, taking decades or centuries. Only once the tracks are laid can the fast trains run. However, even if we are limited to subluminal speeds traveling slower than light, the warp shell is still a revolutionary technology. This is a point often missed in the hype about faster than light. Bobrick and Martier pointed out that a subluminal warp drive is incredibly useful. Remember the time dilation problem? If you travel to Alpha Centauri at 99% of the speed of light in a normal rocket, you age a few months, but people on Earth age years. However, if you travel at 99% of light speed inside a warp shell, there is no time dilation. The shell modifies the space-time metric so that the proper time inside matches the proper time outside. This means we could have a civilization that travels at near light speeds without the desynchronization of families and history. We could reach the stars in a human lifetime without leaving our loved ones behind in the dust of history. A slow warp drive is still the holy grail of relativistic commerce and diplomacy. Furthermore, the shape of the shell matters. Alcubierre envisioned a sphere. Bobrick and Martier showed that the shape could be a flat disk, a cylinder, or a toroid. A flat, coin-shaped warp shell moving face-on requires significantly less energy than a sphere. This allows for the flat-pack warp drive. The ship could be a wide, thin disk, maximizing the cross-sectional area while minimizing the volume of the high-energy shell wall. This geometric flexibility gives engineers variables to play with. We can optimize the aerodynamics of space-time. We can design shapes that minimize the drag of the interstellar medium, or shapes that are easier to accelerate. The flying saucer shape, reported in so many science fiction stories and UFO sightings, actually turns out to be an optimal configuration for a positive energy warp shell. It is a case where the math catches up to the myth. But let's return to the acceleration problem. If we need to push the bubble, what are we pushing it with? Some theories suggest using a photon rocket approach, blasting unimaginable amounts of light out the back of the shell. Others suggest interacting with the magnetic fields of the galaxy. But the most intriguing possibility is the tachyonic solution. If we can discover or generate particles that naturally move faster than light, tachyon, we might be able to couple the warp shell to a stream of these particles, using them like a cosmic wind. While tachyons are currently hypothetical, the warp shell provides a theoretical framework for how a normal matter object could hitch a ride on a superluminal flow. We wouldn't be breaking the light barrier, we would be stepping into a current that is already flowing fast. This physical understanding of the warp drive also reintroduces the stopping problem with a vengeance. If you are traveling in a warp shell at 10 times the speed of light, and you cannot communicate with the front of the shell because of the horizon problem, and you cannot turn off the drive because you are disconnected from the mechanism, how do you stop? In the railway model, the destination star system would need a catching net, another gateway designed to catch the incoming shell and decelerate it safely. This reinforces the idea that we cannot just fly anywhere. We can only fly to where we have already been. The exploration of the galaxy becomes a bootstrap process. Slow colony ships go out first to build the stations, and the warp network follows behind them. We are not building a Starship Enterprise. We are building the Transgalactic Railroad. There is, however, a wild card in the Bobrick-Martier paper. They suggest that if the energy density of the shell can be modified dynamically from the inside, the passengers might be able to steer the metric. By shifting the mass-energy distribution of the shell, imagine pumping plasma from the left side of the ring to the right side. The ship could alter its trajectory. This is akin to a shifting weight in a rolling ball. It wouldn't solve the propulsion issue, but it would solve the navigation issue. It means the crew isn't entirely helpless. They are pilots of a very heavy, very fast gyroscope. Ultimately, the shift to physical warp drives grounds us in reality. It tells us that we can't just wave a magic wand and go fast. We have to deal with mass, momentum, and energy conservation. It makes the warp drive feel less like a spell and more like a machine. And while machines are limited by the laws of physics, they are also things that can be built, improved, and perfected. We have moved from the era of abstract geometry to the era of space-time mechanics. We are realizing that the galaxy is not a place you simply wish yourself across. It is a place you have to build a bridge across. One heavy, expensive, magnificent span at a time. The tracks are waiting to be laid, and the first spike of that railroad is being forged in the equations we are solving today. We have arrived at the end of our intellectual voyage, a journey that has taken us from the crushing, absolute prison of the light-speed barrier to the liberating, dizzying possibilities of space-time engineering. We have dissected the equations that once said impossible and watched them transform through the brilliance of minds like Alcubierre, Lentz, Bobrick, and Martier into a reluctant but definite possible. We have looked at the terrifying energy requirements shifting from the mass of the universe to the mass of a planet and potentially down to the mass of a moon. We have confronted the paradoxes of time travel, the lethal radiation of the bubble wall, and the navigational blindness of flying faster than light. We have even glimpsed the potential infrastructure of a galactic civilization, replacing the romantic notion of lonely ships with the pragmatic reality of stellar rail networks. But as we stand here holding the mathematical blueprints for the stars in our hands, we must ask the final, most important question. What happens next? Where do we, a species that has barely learned to keep its own planet alive, go from here? The honest answer is that we are entering a cathedral era of physics. In the Middle Ages, architects and stonemasons would lay the foundations of great cathedrals, fully aware that they would not live to see the spires reach the clouds. Their children would build the walls, and their grandchildren would install the stained glass. The warp drive is our cathedral. The breakthroughs we are celebrating today, the positive energy solitons, the Casimir cavity observations, the gravitational wave searches, are merely the breaking of the ground. We are digging the trench for the foundation. It is unlikely that anyone listening to this today will board a ship to Alpha Centauri. We are still in the infancy of energy generation. To power even the most efficient warp shell, we first need to master nuclear fusion, then perhaps antimatter containment, and eventually, we must climb the Kardashev scale to become a civilization that can harvest the ambient energy of the solar system itself. This is a project measured not in years, but in centuries. However, this timeline should not be a source of despair. It should be a source of profound purpose. For the first time in human history, we have a roadmap that extends beyond the next election cycle or the next fiscal quarter. We have a trajectory that leads to the stars. This changes our psychological relationship with the universe. For millennia, the stars were merely lights in the sky, gods to be worshipped, or navigational aids for wooden ships. Then they became distant suns, scientifically interesting but physically unreachable. Now they are destinations, they are geography. When we look up at the constellation of Centaurus, we are no longer looking at a painting on a ceiling. We are looking at a coastline waiting for our arrival. This shift in perspective, from observer to potential traveler, fundamentally alters our species' definition of itself. We are no longer Earthlings, we are pre-interstellar. The pursuit of the warp drive also acts as a forcing function for our maturity as a species. As we discussed, the energy levels required to warp space are synonymous with the energy levels required to destroy worlds. A civilization that can fold space-time is a civilization that has graduated from the petty squabbles of planetary geopolitics. We cannot bring our border wars, our resource conflicts, and our nuclear anxieties into the warp age. If we do, we will simply build faster missiles and destroy ourselves before the first colony ship ever leaves the atmosphere. The Great Filter, the theory that explains why we haven't seen aliens yet, might essentially be a test of character. Perhaps the universe grants the power of the warp drive only to those civilizations that have learned to value creation over destruction. In this sense, the engineering challenge is secondary to the sociological challenge. To reach the stars, we must first deserve them. Furthermore, the realization of warp travel offers the ultimate insurance policy for the human race. As long as we are confined to a single rock, we are vulnerable. A stray asteroid, a supervolcano, or a runaway pandemic could extinguish the light of consciousness forever. We are a single point of failure system. The warp drive changes that. It allows us to become a distributed species, spreading the seeds of humanity, our culture, our music, and our memories across a network of worlds separated by light years. If Earth were to fall, humanity would rise elsewhere. We would become extinction-proof, weaving our story into the very fabric of the galaxy. This is the ultimate biological imperative: to survive, to expand, and to ensure that the song of life does not end with the planet that gave it birth. We must also consider the silence of the universe. We have looked for signals and heard nothing. But now, equipped with the knowledge of how difficult, dangerous, and energy-intensive warp travel is, that silence feels less like emptiness and more like efficiency. Advanced civilizations are likely not broadcasting radio waves like chaotic children. They are likely moving silently along the warp highways, conserving energy, shielding themselves from the void, and bypassing the quiet backwaters like our solar system. We are not necessarily alone, we are just unconnected. We are the isolated tribe on an island, unaware of the jet planes flying high in the stratosphere above us. Developing the warp drive is our way of building a raft to leave the island and join the global community. It is the threshold of cosmic adulthood. As we conclude this deep dive, remember that the impossible is a moving target. In 1895, Lord Kelvin, one of the greatest physicists of his time, stated that heavier than air flying machines are impossible. 8 years later, the Wright brothers flew at Kitty Hawk. In the 1920s, we thought the Milky Way was the entire universe. Today, we know there are 2 trillion galaxies. In the 1990s, we thought warp drive required the energy of the universe. Today, we know it requires the mass of a moon. The arrow of progress only points one way. The equations are on our side. The geometry is waiting to be bent. The only variable left in the formula is our own determination. So, the next time you look up at the night sky, do not see a void, see a laboratory, see a vast, waiting ocean that is challenging us to build a better boat. The silence you hear is not an absence of life. It is the holding of breath before the plunge. The work has begun in the quiet corners of university physics departments and the clean rooms of propulsion labs. The dream is no longer a fantasy, it is a project, and although we may not be the ones to step onto the bridge of the first starship, we are the ones who are deciding to build it. We are the architects of the infinite. The bars of the cosmic prison are bending, and for the first time, we can feel the breeze from the other side. Thank you for joining us in the Still Science Lab. Keep looking up. The future is coming faster than light. As we stand at the threshold of this new era in physics, holding the mathematical keys to the cosmos, it is easy to let our imaginations jump straight to the finish line. We envision sleek starships docking at orbital stations around distant exoplanets, trade routes spanning the spiral arms of the Milky Way, and a humanity fully integrated into the galactic community. However, history teaches us that the path from a theoretical breakthrough to a deployed technology is never a straight line. It is a ladder, and currently, we are standing on the very first rung. To truly understand the future of the warp drive, we must stop looking at the horizon and start looking at the ground beneath our feet to identify the intermediate technologies, the stepping stones that will bridge the gap between the chalkboard equations of Alcubierre and Lentz and the actual construction of a superluminal vessel. This phase is not about the breakthrough, it is about the grind, the centuries-long process of mastering energy, matter, and information on a scale we are only just beginning to comprehend. The first and most immediate hurdle on this roadmap is the energy storage problem. We have established that modern warp metrics have reduced the fuel requirement from the mass of the universe to the mass of a planet, and potentially down to the mass of a moon or large asteroid. While this is a victory for physics, it is still a nightmare for engineering. Our current chemical rockets are essentially controlled bomb explosions. They are inefficient and heavy. To power a warp bubble, we need an energy density that exceeds nuclear fusion by orders of magnitude. This points inevitably toward antimatter. When matter and antimatter collide, they annihilate completely, converting 100% of their mass into pure energy. Obeying Einstein's E equals mc squared with ruthless efficiency. It is the most potent fuel source permitted by the laws of physics. Currently, we can only produce antimatter in particle accelerators like the Large Hadron Collider, atom by atom, at a cost of trillions of dollars per gram. To become a warp-capable civilization, we must transition from an economy based on burning carbon to an economy based on harvesting or manufacturing antimatter on an industrial scale. This might involve building vast solar arrays close to the sun to power particle colliders, or harvesting naturally occurring antimatter from the Van Allen radiation belts or the storms of gas giants. However, before we ever build a ship that breaks the light barrier, we will almost certainly build ships that utilize warp technology to stay below it. This is the concept of the subluminal warp drive, and it is likely to be the dominant form of propulsion for centuries before we achieve true interstellar flight. A subluminal warp drive uses the same geometry, expanding space behind and contracting it in front, but it does so gently. The primary advantage here is not speed, but inertial dampening. As we discussed, a conventional ship accelerating at high speeds would crush its crew. A subluminal warp bubble removes this limitation. It would allow a ship to accelerate constantly at high rates, perhaps reaching 10 or 20% of the speed of light in a fraction of the time a rocket would take, all while the crew floats in zero-gravity comfort. These pre-warp ships would open up the solar system, turning the trip to Mars from a 6-month ordeal into a weekend commute. They would be the testing ground where we learn to stabilize the bubble, manage the radiation, and navigate the metric without the existential risk of leaving the causal universe. Another critical stepping stone is the development of metamaterials and exotic matter manufacturing. The walls of a warp bubble require the manipulation of energy densities that would vaporize normal matter. We cannot build the hull of a warp drive out of titanium or steel. We need materials that are engineered at the atomic level to withstand extreme gravitational shearing and electromagnetic flux. This connects to the current revolution in condensed matter physics. We are beginning to create materials that can bend light, conduct electricity without resistance, and exhibit properties not found in nature. The hull of a warp ship might be printed from a programmable matter lattice, a substance that can change its density and structural integrity in real time to adapt to the fluctuations of the warp field. We are essentially talking about solidified energy, a material state that acts as a physical interface between the ship's machinery and the chaos of the space-time distortion. Furthermore, the navigation of a warp ship requires a computational leap that parallels the propulsion leap. A human pilot cannot react to changes in the space-time metric when moving at superluminal speeds. Even a standard supercomputer is too slow. The variables involved in maintaining a stable soliton, balancing the energy density, correcting for gravitational anomalies, and adjusting the bubble geometry change at the Planck timescale. This necessitates the integration of quantum computing. A warp drive is not just an engine, it is a quantum state machine. The ship's computer must be able to process probabilistic data, making decisions based on the quantum superposition of possible futures to steer the ship through the safe trajectories of space-time. The pilot of the future is not a person with a joystick. It is a cooling chamber, housing a qubit array, entangled with the sensors on the hull, making micro-adjustments billionths of a second faster than any biological brain could perceive. We must also visualize the first light of this technology. It will not be a grand spaceship like the Enterprise leaving dry dock with a fanfare. The first warp drive will likely be a warp Sputnik, a tiny, unmanned probe, perhaps no larger than a toaster, equipped with a microscopic Casimir energy generator. Its mission will be simple: to create a microscopic warp bubble, sustain it for a nanosecond, and move a distance of a few meters in a laboratory vacuum chamber. This unglamorous experiment will be the most significant moment in human engineering history. It will prove that we can move an object by moving space. From there, the scaling law takes over. We will scale up to drone ships, sending automated probes to Proxima Centauri to scout the system. These probes will be the pathfinders, mapping the gravitational terrain, testing the radiation shielding, and perhaps establishing the initial communication buoys that will eventually guide the manned missions. Finally, we must consider the geopolitical, or rather exopolitical, implications of this technological ladder. The nation or corporation that masters the subluminal warp drive first effectively owns the solar system. The ability to move cargo and people between planets in days rather than months creates an economic hegemony that will redefine power structures on Earth. We are likely to see a new space race, but unlike the race to the moon, which was driven by ideology, this race will be driven by resource acquisition and logistical dominance. The warp drive is the ultimate engine of commerce. As we build the infrastructure, the antimatter factories, the quantum navigation beacons, the metamaterial foundries, we are inadvertently building the economy of a Type 1 civilization. The road to the stars is paved with the mundane necessities of supply chains and profit margins. This brings us to a sobering realization. The warp drive is not a magic wand that saves us from ourselves. It is a magnifying glass that amplifies who we are. If we remain a divided species, the warp drive becomes a mechanism for extending our conflicts into the stars. If we evolve into a cooperative species, it becomes the nervous system of a unified humanity. The technology is neutral, the application is moral. As we grind through the hard parts of the roadmap, the centuries of engineering, the failures, the trillions of dollars in investment, we are buying time to mature sociologically. The difficulty of the task is a feature, not a bug. It forces us to grow up. We are currently in the adolescence of our species, playing with dangerous toys. The journey to build the warp drive is the rite of passage that will usher us into adulthood. We are not just building a ship, we are building the civilization capable of flying it. The blueprints are ready. The physics is sound. Now the real work begins. The era of dreaming is over. The era of construction has begun. As we project our vision further into the warp era, we must look beyond the machinery and the mathematics to the most malleable and unpredictable variable in the equation: humanity itself. The invention of the warp drive is often compared to the invention of the wheel or the internal combustion engine, but these comparisons are woefully inadequate. A better analogy would be the moment the first lungfish dragged itself out of the ocean and onto dry land. The warp drive does not just change how we travel, it changes where we can exist, and consequently, what we will become. We are standing on the brink of a biological and cultural divergence that will fracture the singular definition of human and shatter it into a kaleidoscope of new identities. When we step onto a ship capable of outrunning light, we are not just explorers, we are the ancestors of a new genus of hominids that will be shaped by the environments of distant stars. Consider the biological implications of colonization enabled by warp travel. While the drive allows us to cross the void in months rather than millennia, the destinations we reach will not be duplicates of Earth. Proxima Centauri b is bathed in ultraviolet flares. A colony there would likely live underground or under massive shielded domes. The gravity on a super-Earth, like Kepler 452b, might be 50% stronger than what we are used to. Over generations, the humans living there would physically adapt. Their bones would become denser, their stature shorter and more muscular to combat the gravitational load, and their cardiovascular systems would evolve to pump blood against the increased pressure. Conversely, humans born in the low-gravity environments of orbital habitats or small moons would become tall, slender, and fragile, unable to ever stand on the surface of Earth without mechanical exoskeletons. The warp drive maintains the connection between these worlds, but it cannot stop the march of evolution. Within a few centuries of the first warp flight, humanity will no longer be a single species, but a family of related species, separated by the stars, but connected by the warp network. This physical divergence will be mirrored by a cultural divergence. The psychological distance created by warp travel is still significant. A 3-month journey to Alpha Centauri is short enough to maintain trade, but long enough to foster independence. The colonies will not be suburbs of Earth. They will be sovereign nations with their own ideologies, their own dialects, and eventually their own languages. We will see the rise of solar nationalism, where a citizen's primary loyalty is to their home star, not to the terrestrial nations that launched the original ships. The warp drive prevents total isolation. It stops the colonies from forgetting Earth entirely, but it facilitates a federal structure of the galaxy. Earth will transform from the master of the species into the old world, a museum planet, and a biological reserve, revered as the ancestral homeland, but perhaps looked upon with a mix of nostalgia and pity by the dynamic, hardy civilizations expanding on the frontier. The political center of gravity will shift away from Sol, pulling the future of our history toward the resource-rich, energy-dense clusters of the galactic arm. Economically, the warp drive creates a market dynamic that has no precedent in history. In a conventional maritime or aerial economy, we ship raw materials, grain, oil, steel. But in an interstellar warp economy, the cost of moving mass is astronomical. You cannot fill a warp ship with iron ore and make a profit. The energy required to accelerate that mass to 10 times the speed of light exceeds the value of the ore by 1 billion times. Therefore, the interstellar trade will be exclusively a trade of high-density value. What is worth shipping at Warp 10? Information, genetic codes, rare, synthesized isotopes that cannot be produced naturally, antimatter, art, and, most importantly, people. The warp ships of the future will not be freighters. They will be packets of data and biology. We will see the rise of an information empire, where the currency is not gold, but patents and blueprints beamed or couriered between stars. A colony on Trappist, one might discover a cure for cancer in the local fungal life. That physical sample is worth the warp journey back to Earth. The economy will be defined by the premium of novelty, the value of things that can only be found out there. Furthermore, the introduction of warp travel forces us to construct a new framework of galactic bioethics. When we land on a new world, even if it seems barren, we bring with us the microbial heritage of Earth. Our bodies are walking ecosystems of bacteria and viruses. If we step onto a planet with its own nascent biosphere, perhaps just simple, single-celled organisms, in a primordial soup, we risk contaminating it instantly. Our aggressive Earth bacteria could wipe out the native life, or conversely, a native pathogen could jump to us and start a plague that a warp ship then carries back to Earth before anyone realizes the danger. The quarantine protocols for warp travel will be the strictest laws in existence. We might see the creation of bio-firewalls, orbital stations where travelers must spend weeks being sterilized and screened before they are allowed to descend to a planet or return to Earth. The freedom of the stars comes with the terrifying responsibility of not becoming the invasive species of the galaxy. We have invasive kudzu and rabbits on Earth. We do not want to be the kudzu of the Milky Way. This leads to the inevitable question of the other. As we expand our reach with warp technology, the statistical probability of encountering another intelligent civilization approaches certainty. The warp drive is the technology that allows us to enter the Galactic Club, but it also makes us visible. For centuries, we have been quiet, stuck on our rock. Now, we are lighting up the gravitational spectrum with our engine signatures. We are making noise. This brings us back to the dark forest theory, which suggests that civilizations stay quiet to avoid predation. By building a warp drive, we are effectively walking into a dark forest and lighting a flare. We must ask ourselves if we are ready for what might notice the light. Are the other civilizations benevolent Federation builders? Or are they territorial empires that view any new warp-capable species as a potential threat? The sociology of the warp era is not just about how humans interact with humans. It is about how humans position themselves in a food chain we do not yet understand. We are the new kids in a very old neighborhood, and we don't know the rules of the gang that runs the block. However, there is an optimistic view of this sociological shift. The overview effect, experienced by astronauts who see Earth from orbit, creates a cognitive shift toward global unity. The galactic perspective, experienced by a civilization that travels between stars, could create a shift toward species unity. When you are 4 light years from home, the differences between a Russian, an American, and a Chinese astronaut evaporate. They are simply Earthlings. The harshness of the void and the shared challenge of survival might force humanity to finally abandon the tribalism that has plagued us for millennia. The warp drive might be the mirror that finally shows us who we are. A single, fragile, biological entity struggling to keep its candle lit in a windy darkness. The wars of the future might not be fought over borders on a map, but over the preservation of the human spark in a universe that is indifferent to our existence. Ultimately, Part 12 is about the realization that the machine is the easy part. Building the warp drive requires solving equations and bending metal. But building a warp civilization requires rewriting the software of the human mind. It requires us to expand our empathy to encompass distances that light takes years to cross. It requires us to become long-term thinkers, planting trees on planets we will never visit, for grandchildren we will never see. It challenges us to define what it means to be human when human no longer means of the Earth. As we prepare to turn the key on the first prototype, we must understand that we are not just launching a ship, we are launching a new epoch of history. We are leaving the cradle, and as any parent knows, the moment a child walks out the door is a moment of terrifying, beautiful, irreversible change. We are about to walk out the door, and there is no turning back. As we reach the conclusion of this extensive exploration into the mechanics and implications of faster-than-light travel, we must pull back the camera one last time. We have zoomed in on the quantum equations of the Casimir effect, the thermal dynamics of the warp bubble, and the sociological fractures of a multiplanetary species. Now, we must zoom out to the widest possible lens, the timeline of the universe itself. When we talk about the warp drive, we are often distracted by the immediate thrill of exploration, the flag planting, the alien landscapes, the rush of discovery. But in the grand calculus of cosmic history, the warp drive is not a tool for curiosity, it is a tool for survival. It is the only technology capable of solving the ultimate problem that faces every civilization that ever emerges from the primordial slime, the problem of entropy and the inevitable death of the home star. Our sun is a middle-aged star. It has burned for 4.5 billion years, and it has roughly 5 billion years left before it exhausts its hydrogen fuel, swells into a red giant, and consumes the inner planets, including Earth. Long before that final incineration, the increasing luminosity of the sun will boil our oceans and strip away our atmosphere. If humanity, or whatever we evolve into, remains confined to the solar system, our story has a definite, unavoidable, final chapter. We will be erased, and all our art, our science, our history, and our struggles will be as if they never happened. The warp drive offers the only escape clause from this death sentence. It is the difference between a civilization that is a temporary biological accident and a civilization that is a permanent feature of the cosmos. By mastering the ability to move between stars, we decouple our destiny from the life cycle of a single fusion reactor. We become nomadic, capable of migrating across the galactic arm, moving from dying stars to young ones, effectively outrunning the thermodynamic clock of our local neighborhood. Furthermore, we are racing against the expansion of the universe itself. We live in a cosmos that is stretching apart. Distant galaxies are moving away from us faster than the speed of light due to the expansion of space. Every second, more of the universe crosses the cosmic horizon and becomes forever unreachable, even to a beam of light. If we are limited to subluminal rocket travel, our reach is shrinking every day. We are becoming trapped in a lonely island of galaxies. The warp drive is the only theoretical mechanism that allows us to fight back against this isolation. By moving faster than the expansion, or by taking shortcuts through the geometry of space-time, we can maintain a connection to the broader universe. We can keep the lights on in the cosmic house rather than being relegated to a single darkening room. The pursuit of this technology is a rebellion against the fundamental loneliness of the Big Freeze. This perspective reframes the current cost and difficulty of warp research. Critics often argue that we should fix the problems on Earth before looking to the stars. This is a false dichotomy. We must do both. We must fix our planet to ensure we survive the next century, but we must look to the stars to ensure we survive the next eon. The investment in warp physics is an investment in existential redundancy. It is the creation of a backup drive for the human experience. Just as the Library of Alexandria was burned and its knowledge lost because it existed in only one place, the Library of Earth is currently vulnerable because it exists on only one rock. Spreading to the stars is the act of digitizing our existence, copying the files of life to multiple servers to ensure that a single catastrophe cannot delete the database of consciousness. There is also a profound psychological imperative at work here. A civilization that stops exploring is a civilization that begins to die. History shows that societies that turn inward, that close their borders and stop seeking the new, inevitably stagnate and collapse. The frontier serves as a pressure valve for human ambition. It challenges us, scares us, and forces us to innovate. Without the challenge of the impossible, our spirit withers. The warp drive provides the ultimate frontier. It offers a challenge that will occupy our best minds for 1,000 years. It gives us a common project that transcends national borders. It answers the nihilism of the modern age with a definitive purpose. We are the universe trying to understand itself, and to do that, we must go everywhere and see everything. We are currently the bridge generation. We are the people born too late to explore the continents of Earth and too early to explore the stars. It is a frustrating position to be in. We grew up watching science fiction that promised us jetpacks and starships, and instead we got the internet and smartphones. But we must not mistake our position for irrelevance. We are the architects, the scientists working on negative vacuum energy today, the engineers designing fusion reactors, and the theoretical physicists grappling with the Alcubierre Metric are laying the foundation stones of the cathedral. We will not see the spire, but the spire cannot exist without the trench we are digging now. Our job is to keep the dream alive, to fund the research, to teach the math, and to preserve the optimism that says, this is possible. The silence of the universe is not a sign that we are alone. It is a sign that the barrier is high. The fact that we do not see warp ships zooming past Earth suggests that the transition from a planetary civilization to an interstellar one is the hardest filter in existence. It requires a species to survive its own technological adolescence, to master nuclear power without blowing itself up, to master biotechnology without creating a plague, and to master planetary stewardship without exhausting its resources. If we can solve the warp drive, it means we have likely solved all those other problems too. It means we have grown up. The ship is the prize for winning the game of civilization. So, as we close this chapter, let us replace the feeling of impossibility with a feeling of inevitability. The laws of physics do not forbid the warp drive. They merely demand a high price for admission. We are slowly, methodically gathering the currency to pay that price. We are harvesting the knowledge, generating the energy, and refining the materials. It may take a century, or it may take a millennium, but the human drive to see what is over the next hill is an unstoppable force of nature. We cross the oceans in wooden boats. We cross the sky in canvas planes. We cross the void to the moon in tin cans. We will cross the stars in bubbles of bent space-time. It is not a question of if, it is a question of when. And when that day comes, when the first human crew watches the sun shrink to a star and then disappear as they engage the drive, they will carry with them the hopes of every dreamer who ever looked up at the night sky and wondered, what's out there? That future is being written now, in the equations and the experiments of today. The journey has already begun. As we chart the course toward a superluminal future, we must navigate a treacherous logical trap that has paralyzed long-term space exploration concepts for decades. The paradox of incessant obsolescence, often called the weight calculation. This paradox posits a cruel reality. If we launch a starship today, traveling at 10% of the speed of light, it will take 40 years to reach Proxima Centauri. However, if we wait 20 years to develop a ship capable of traveling at 50% of the speed of light, that second ship will launch 2 decades later, but arrive years before the first ship. The crew of the first vessel would be overtaken in the deep void, watching the newer, faster ship streak past them, rendering their sacrifice and their journey effectively meaningless. This logic creates a paralysis where the optimal strategy always seems to be wait for better technology, potentially postponing the launch forever. In the context of the warp drive, this paralysis is even more acute. Why build a subluminal warp shell today if a true superluminal drive is only a century away? The solution to this paradox lies in shifting our objective from destination to infrastructure. We must stop thinking of interstellar travel as a series of isolated sprints to the finish line and start viewing it as the construction of a permanent bridge. The early, slower ships are not failures if they are overtaken. They are the layers of the foundation. Their mission is not just to arrive, but to test the telemetry, to map the gravitational anomalies of the interstellar medium, and to deploy the communication relays that the faster ships will require. The crew of the slow ship is not racing the crew of the fast ship. They are the road crews paving the highway for the sports cars that will follow. We must accept that the first generation of warp travelers will be surpassed by their grandchildren, and that this is not a tragedy, but a triumph of the process they initiated. Furthermore, the acceleration of this timeline is no longer solely dependent on the limitations of the human biological brain. The greatest accelerator of warp drive research in the 21st century is not a new equation, but a new thinker: artificial general intelligence. The mathematics of the Alcubierre Metric and the Lentz soliton involve topology and energy tensors of such complexity that they push the very boundaries of human cognitive capacity. We are trying to visualize four-dimensional curvature with three-dimensional brains. Artificial intelligence, however, suffers from no such limitation. We are entering an era where AI systems can run billions of simulations of warp bubble geometries per second, optimizing the shape of the shell to minimize energy requirements in ways that a human physicist might take a lifetime to discover. We are already seeing this synergy in materials science. Deep learning algorithms are currently scouring the vast chemical space to identify candidate structures for the metamaterials needed to build the warp hull materials that can withstand the intense tidal forces of the bubble wall. It is highly probable that the specific design of the first working warp drive will be generated by a silicon intelligence, a design so complex and non-intuitive that human engineers will build it without fully understanding why it works, only knowing that the math checks out. The warp drive thus becomes the child of the technological singularity, a machine that requires a transhuman intelligence to conceive. This convergence suggests that the bottleneck is not physics, but computation. As our computers get faster, the stars get closer. However, even with AI, there is one final theoretical wall that must be breached: the unification of physics. Currently, our understanding of the universe is fractured. We have general relativity, which describes gravity and the curvature of space-time, the macro world, and we have quantum mechanics, which describes particles and fields, the micro world. The warp drive sits uncomfortably right in the crack between them. It uses the geometry of relativity, but relies on the energy states of the quantum vacuum. To build a safe, reliable drive, these two theories must be welded together into a grand unified theory, or quantum gravity. We need to understand exactly how the quantum vacuum generates space-time curvature. Without this Rosetta Stone, we are essentially trying to build a nuclear reactor using alchemy. We might get lucky and make it work, but we risk catastrophic failure. The quest for the warp drive is therefore identical to the quest for the theory of everything. This necessity forces a realignment of our scientific priorities. It means that building bigger particle colliders and more sensitive gravitational wave detectors is not curiosity science. It is the direct R&D pathway to interstellar flight. Every time we smash protons together at the LHC, we are looking for the graviton, the theoretical particle that carries the force of gravity. If we can find the graviton and learn to manipulate it, we stop being passive observers of gravity and become its masters. At that point, the energy requirements for a warp bubble might drop from the mass of a planet to the output of a battery, because we would no longer be fighting space-time with brute force, we would be picking the lock. Sociologically, the pursuit of this technology requires a transition from a scarcity mindset to an abundance mindset. A civilization that fights over oil reserves will never build a warp drive, because the energy investment required for the initial experiments is too high to justify in a zero-sum economy. The warp drive requires a post-scarcity economy, likely powered by fusion energy, where the allocation of resources to massive, multi-generational projects does not mean starving a population. We must solve the energy equation on Earth, providing cheap, clean, abundant power to every nation before we can spare the terajoules needed to bend the sky. The path to the stars leads through the fusion reactor. You cannot have Star Trek physics with Stone Age economics. Ultimately, Part 14 brings us to the realization that the warp drive is not an isolated technology. You cannot just invent it in a garage. It is the capstone of a civilization-wide pyramid. It requires the base of clean energy, the middle tiers of AI and material science, and the apex of unified physics. It is an emergent property of a mature planetary society. This implies that if we want to go to the stars, we don't just need better rockets, we need a better world. We need a world that is stable enough to plan for centuries, wealthy enough to invest in the unknown, and unified enough to pool its cognitive resources. The barrier to the stars is not the speed of light, it is the coherence of our civilization. As we look to the future, we should not see the warp drive as a distant fantasy, but as the inevitable result of our current trajectory, provided we can keep our civilization intact. We are the pattern-seeking animals who learn to navigate the oceans by the stars. It is written in our code to eventually navigate the stars themselves. The weight calculation is broken by action. By building the precursors, the probes, and the theories today, we ensure that the future has something to improve upon. We are not waiting, we are working, and somewhere in a server farm, humming with AI calculations, or in a chalkboard equation being scribbled by a student who is just realizing the connection between vacuum energy and gravity, the key is turning. The door is unlocking. The galaxy is holding its breath, waiting for us to take the step. We have now reached the terminus of our long conceptual voyage, a journey that has taken us from the dry, dust-covered chalkboards of theoretical physics to the shimmering, hypothetical bows of starships riding the waves of space-time. We have dissected the Alcubierre Metric, grappled with the terrifying energy requirements of the warp bubble, and peered into the microscopic quantum machinery of the Casimir effect. We have confronted the paradoxes of time, the dangers of radiation, and the profound sociological metamorphoses that await a civilization brave enough to leave its cradle. It has been an odyssey of the mind, stretching our understanding of what is possible and challenging the very definitions of distance and destiny. As we stand here at the end of this series, it is important to recognize that the warp drive is more than just a potential engine for a spaceship. It is a mirror. It reflects our ultimate ambition as a species. It represents the refusal to accept boundaries, the refusal to be trapped by the arbitrary speed limit of light, and the refusal to let the story of humanity end on the same rock where it began. When you step outside tonight and look up at the vast, scattered arch of the Milky Way, I want you to see it differently than you did before we started this journey. Do not see it as a cold, unreachable void or a static backdrop of twinkling lights. See it as a geography. See it as a map of waiting coastlines and undiscovered continents. Every single point of light you see is a sun, likely hosting a family of worlds. And thanks to the physics we have explored, we now know that there is a pathway to reach them. It is a difficult path, paved with immense engineering challenges and energy barriers that will take generations to dismantle. But it is a path that exists. The laws of the universe do not forbid us from crossing the stars. They simply demand that we grow up, that we master our resources, and that we unite our intelligence before we are allowed to make the crossing. The silence of the night sky is not a sign of emptiness. It is a quiet invitation. It is the universe holding its breath, waiting for us to take the leap. This series has been a testament to the power of human curiosity. We started with a "what if" question, what if we could move space instead of the ship, and followed that thread through decades of research, witnessing how a single idea can evolve from a science fiction trope into a serious field of study involving the brightest minds on the planet. This is how progress happens. It does not happen in a sudden flash of magic. It happens in the slow, grinding pursuit of knowledge, in the willingness to be wrong, to revise our models, and to keep pushing against the impossible until it breaks. You, by engaging with these ideas, by learning about solitons and energy densities and time dilation, are part of that process. You are keeping the dream alive. Public interest is the soil in which the seeds of science grow. If we stop dreaming about the stars, we will stop building the ladders to reach them. Therefore, your curiosity is just as essential to this mission as the equations on the physicist's blackboard. As we close the book on the warp drive for now, remember that we are living in the cathedral era of this technology. We are laying the foundations for a structure we may never inhabit, but we build it so that our children's children might one day walk through its doors and step out onto the soil of another world. There is a profound nobility in that long-term thinking. It lifts us out of the petty distractions of the moment and connects us to a timeline that spans thousands of years. It reminds us that we are the ancestors of a galactic civilization, and the choices we make today, how we fund science, how we treat our planet, how we educate our youth, will determine whether those future ships ever launch or whether they remain forever as unfulfilled equations. We carry the fire of the future in our hands. We must also hold on to the humility that this subject teaches us. The universe is vast, ancient, and complex beyond our current comprehension. We have scratched the surface of gravity and quantum mechanics, but there are deep oceans of mystery left to explore. We might find that the warp drive is just the first primitive step, and that realities await us that are even stranger and more wonderful than bending space-time. Science is an endless horizon. The more we walk toward it, the further it expands. That is not a discouragement. It is a promise of eternal adventure. We will never run out of things to discover. We will never run out of frontiers. As long as there is a question left to ask, humanity has a purpose. I hope this deep dive into the mechanics of the impossible has sparked a light in your imagination. I hope it has given you a sense of optimism about what we are capable of achieving. In a world that is often filled with cynical news and short-term crises, the warp drive stands as a monument to what we can do when we look up and work together. It is the ultimate expression of hope, the belief that there is a future out there waiting for us, and that we have the power to build a bridge to reach it. Thank you for taking this journey with me. Thank you for lending your time and your mind to the contemplation of the infinite. It has been a privilege to explore these concepts with you. As the screen fades to black, carry this perspective with you. Look at the stars with the eyes of an architect, not just an observer. The galaxy is our garden, and the gate is just beginning to creak open. So, from the quiet hum of the still science lab, where we turn the impossible into the inevitable, I wish you a peaceful evening. May your dreams be as limitless as the cosmos we have discussed. Good night, sleep well, and keep your eyes on the horizon. I will see you in the next video.